Hello, it's me, Ashutosh Sharma, and so I'm presenting my presentation on unit tests, and here I go. So, what is unit testing? That's a good question. So, unit test is a type of testing that analyzes individual units slash components of a software application in isolation. Units are the smallest testable parts, and examples are functions, methods, classes. They are also isolated from the rest of the application. So the main priority in unit testing is to check whether each unit of code behaves as expected according to its design and requirements. And this is very important because you need to know if this code is behaving as expected according to your designs or requirements. If that's not the case, then there will be a bunch of errors, and that's going to take a long process in the debugging cycle. So it's best that you check that the codes are behaving as expected so you don't run into these type of issues. So the key aspects of unit testing. Key aspects of unit tests follows its core principles and practices that contribute to the effectiveness in the software development. The key aspects in unit testing is one, isolation. And I've also given a definition. So, unit test main priority is testing individual units of code in isolation. So, this means that each unit is tested independently without the reliance of any external systems. Another aspect is regression testing. So, regression test ensures that any new changes slash additions does not break existing functionalities. This will help in keeping stability and reliability in the software as it changes. Another example would be debugging aid. This helps in pinpointing errors or unusual behavior in specific units of code. When the test slash code fails, it provides valuable information about the issue and aids in the debugging process. So I think that's why I choose the debugging aid example, is because it provides those valuable information in the debugging process. And it helps, like, in a sense, step by step, help the developer pinpoint where those errors are. Because if he's just doing it by himself, it's going to take a lot of time and it'll just be very hard. So you have unit test assertions. Assertions is used because it explains the primary role of assertion in unit testing by validating the expected outcome against actual results. Some assertion methods that were used in the video were assert equals for array comparisons. Assert equals was used for primitive values or objects. Then there was also assert false, which was used to verify the condition. Assert null and assert not null were used for object comparison. There was also a parameter order in the assertion statement, and it would consider the expected value, comma, actual value, comma, and failure message. Basic tests. The advantages of using basic test in unit testing is that it emphasizes automation and the ability to verify test results. Another advantage is the ease of running multiple test cases simultaneously and also compare expected results from actual results. And another key factor from the video is naming conventions, such as adding suffix to the class names and organizing them in separate test packages. So I think that is one of the advantages for basic test is that you're able to run multiple test cases simultaneously. So and at the same time no errors. So I think that is one big advantage. Exception handling. So the purpose of exception handling is the importance of testing a program on how it handles exceptions and errors when mistakes occur. Some examples from the exception video is the index out of bounds exceptions or arithmetic exceptions. They use these exceptions to test to access invalid array indexes and see how codes can handle this scenario and see how it responds. The benefits of exception handling is during the debugging process. When users identify exception, having an understanding of why this error occurred, it helps developers in fixing this issue quickly. So I think I think that is why in unit testing there are so many features and requirements, but each requirement has its benefit. And with exception handling, it's very helpful in that debugging process because there's going to be a lot of bugs, and having this like exception handling system, it helps developers in fixing whatever issues they have in a faster time frame if it was just by themselves. If it was by themselves, it would have been a very long process. So unit test by Martin Fowler. We transition to Martin Fowler. who had some really interesting things to talk about regarding unit tests. Things that stood out was regarding unit test definition. To my understanding, unit testing is a software development process in which the smallest testable parts of the application, called units, are individually tested for proper operations. But from Martin's perspective, he says that any group slash team can have different definitions of unit test. It doesn't have to be just one criteria that you have to follow. Other key points that stood out was Fowler discussing the debate between solitary test, that is dependencies using test doubles and sociable tests, allowing interaction with real collaborators, explaining how it can lead to different styles of testing. Another thing he talks about is test suits usage and how he explains the differences between a compile suit, which runs a lot during the coding process, and a commit suit that is part of a continuous integration. He explains how both concepts helps in identifying errors. He mentions that the need for small unit testing and how it can run regularly during development. The benefits is that it can detect error, such bugs when there are changes. So that is one benefit, that after making changes, you know, it can detect any error, so that that saves the user and developer so much time. Differences between mocks and stubs. The differences between mocks and stubs is that with stubs, it provides a predetermined response to calls made during the test. With mocks, it's more pre-programmed with expectations to explain and verify the calls they expect to receive. With implementation from the stub side, it only responds to what it is programmed to test for. It doesn't test anything outside from what it's supposed to test. With the mocks, it's more predefined method calls that they will receive during the test. From the verification side of stubs, they primarily use state verification so they can keep track of the changes made during testing for verification reasons. From mock side, it insists of behavior verifications. It verifies if the system under test works correctly with its collaborators by checking if the method calls occurred. And one other difference is with their usage steps. They are used for simpler slash predetermined responses. With mocks, it's used to test interactions between different components and objects. Test-driven development. Martin Fowler explains how test-driven development is used repeatedly when building a test. He emphasizes that writing the test before the code is beneficial because it helps developers in ensuring that the code is testable and meets the developer's requirements. Fowler also pointed out that many developers' mistakes in test-driven development is neglecting the third step called refactoring. Neglecting refactoring can lead to poorly designed code, and that's why he emphasizes developers to always use refactoring. The positives of using it leads to organized and structured code and decreases the risk for fragmented code segments that could lead to the system to fail. So this really stood out to me the most, that what Martin was pointing out, that many developers, you know, they leave the stage of refactoring because if you have so many lines of code and they're not refactored or organized properly, to a regular person it's going to be a mess, that it's not going to be organized, understanding where is each component located, or it's just going to be a mess for a regular person uh, to understand what that user developer has made. So I think for any other, rising developer, software engineer, I think they should definitely uh, use refactoring because you've put so much effort, and if you do not organize your code, it's just not going to look good from your end and for that user who's going to try to read it. What makes a good unit test? From the answers regarding what makes a good unit test, the ones that I agree with is, quote, tests should test only one thing at a time. Multiple assertions are okay as long as they are all testing one feature slash behavior. When a test fails, it should pinpoint the location of the problem. And tests should not rely on each other. They should be, I think, isolated. No assumptions about order of text execution ensures a clean slate before each test by using setup slash teardown appropriately. Then you have professionals. So in the long run, you will have as much test code as production if not more. Therefore, follow the same standard of good designs for your test code. Well-factored method dash classes with intentions of revealing names, comma no duplication, comma tests with good names. Good test also runs fast. So any test that takes over half a second to run needs to be worked upon. The longer the test suite takes to run, the less frequently it'll be run. So the more changes the developer will try to sneak in between runs, and if anything breaks, it will no longer figure out, it'll take no longer to figure out which changes was the culprit. So what makes a good unit test? Readable. Tests needs to be maintained just like production code. So make it easy to read, even if it takes more effort. Tests should be symmetric, follow a pattern, and concise. Test one behavior at a time. Use a consistent naming convention, such as, the test doc stuff. Avoid cluttering the test with incidental details. Become a minimalist, in a sense. Um, these examples from both slides are great for beginners to understand how you should create a unit test. Martin Fowler would also concur because he also had similar ideas slash representations like this individual. The code has to be readable. There shouldn't be any cluttering or repetitive code because that can cause confusion to the user or the developer. Martin Fowler would agree that a good test should run fast, just like he has said with his analysis in unit test. A smaller test is beneficial because you can pinpoint errors faster. So the more changes you do, the more time it'll take to find those errors. Key qualities of a good unit test. Some of the key component from Kenneth Truer's article about a good unit test is explaining the levels of a basic unit test. So, a good unit test, a better unit test. He explains in basic unit test that a unit test shouldn't depend on its environment. It should run on any computer slash software. It shouldn't depend on other test units. It shouldn't depend on external data. He goes up a level on what a good unit test should be. It should cover all the paths of the code you want to test. It should assert the results of your code. A better unit test is that it should test and assert edge cases and different range of data, meaning it can handle any type of testing. It isn't just bounded to one type of testing slash software. And does it run fast? And is it well factored slash organized? So I like this from Kenneth Truer's article, how he explained that there are key qualities of good unit test, but he goes even deeper into those levels, saying that there's a basic unit test, what a normal basic unit test should be. Then what is a good unit test? Like how are those, um, implementations used to improve your unit test. And then from a good unit test, there's a better unit test. So a better unit test that, like stated, it should test and assert edge cases and different ranges of data. It's just not bounded to one set of data. So I really like that from Kenneth True's article about levels of good unit tests. And then going deeper into the key qualities, um, good unit test. Kenneth Truer also goes deeper regarding these requirements, like with it shouldn't depend on the environment. What he is trying to say is that the SCM should not require a specific environment. He says, quote, they can't rely on certain settings on your machine. Another example that I liked um, is that it does not depend on other unit tests. What he's trying to say is that if one failing test occurs, make sure there isn't a domino effect, which would fail the other test. Make sure that it can run independently. If you don't, if all the tests failed, you won't be able to find and correct the error. Another one is it shouldn't depend on external data. He points out that ex- accessing accessing your database is a no. Your test should provide that data to your code. The last one that everyone should agree on is it shouldn't have side effects. You don't want a unit test to cause any external effects. So, key qualities of a good unit test. So, going deeper, last one is test a single unit of work. So, Kenneth points out that it is important to test small parts independently. The reason is if you test a huge piece of code, this will lead to maintenance problems. Testing big pieces of code will cause many changes in the system. So if you test smaller codes, yes, there will be some changes, but nothing compared to huge amount. So I think you're getting this, I think, understanding, and I think in most of these articles is that not only is the coding design part important, but it's also the end, the debugging, the organization, like like he's saying, don't test a huge piece of code at once because that's going to lead to a maintenance problem. Too much is just being sent, and there's going to be many changes. Do it in little bits and pieces because sure, the data there'll be some changes, but nothing compared to huge pieces of data. So I think this was a very good component that I think every developer should use. And going forward, for the key qualities of a good unit test, the last one but not least, you want the code to cover all the paths of the code you want to test. So Kennedy points out that if you want a good unit test, you at least have to make sure that all your code is executed at least once. He's saying this because if you can't run it at all, then it's not considered a good unit test. And another component is that it should run fast when you have a unit test. You must have a suit. If you have a suit run, if you have a suit, run it as fast as possible. So I think that was another one of the qualities that I like, that he's saying that it should have like the entirety of the code should run. Because if it cannot run on your end, your software component, what makes you think that it'll run on somebody else's computer, or it's just not, it's just a bad practice. So at least you should see if all your code runs at once from your end. And now we have JavaScript testing units versus functional and integration tests. So each components from Eric Elliott article regarding these three tests are that each test has a unique role in testing. You don't choose between unit test, comma, functional test, comma, and integration test. You use all of them, comma, and make sure you can run each type of test suite in isolation from the others. And going back to the previous slide by Truers, he also stated that you want the test to run independently. I think what any developer should understand from these slides, that you are testing, you run independently. It shouldn't just rely on one computer or a particular software. Everyone should have access to your test. He also explains that you should run three of the testing code separately because uh, it'll be easy to run. And going forward with JavaScript testing, comparing the testing unit functional and integration tests. The reason why he also says to learn all three tests is because you will need to understand that each test has a job to perform, and they fall into these three categories. So you have a user experience test, deals with the end user experience, comma, you have a developer API test, deals with the developer experience, comma, you have an infrastructure test, deals with load tests, common network integration tests, and etc. And he goes on deeper saying users experience tests examine the system from the perspective of the user using the actual user interface, typically using the target platforms or devices. The developer API tests examines the system from the perspective of a developer. And I think the last point uh, that he makes, just like the other authors, you know, is that, you know, um, a unit test must be good and point out bugs. And he explains by saying, whatever test runner and assertion library you use, a failing unit test should tell you at glance one, which component is under test, what is the expected behavior, what was the actual result, you know, um, what is the expected result, and how is this behavior reproduced. And another one is now software testing. So, in software testing, this definition is helpful in giving a board of perspective of what software testing should be. It is the act of examining the artifacts and the behaviors of the software under test by validation and verification. Software testing can also provide an objective, independent view of the software to allow the business to appreciate and understand the risk of software implementation. And the test techniques included, but are not necessarily limited to, is one, you know, analyzing the product requirements for completeness and correctness in various contexts, likely industry perspective, business perspective, feasibility, viability of implementation, usability, and uh, usability and performance and security and infrastructure considerations, and also reviewing the product architecture and the overall design of the product, working with product developers on improvement in coding techniques, design patterns, tests that can be written as part of a code based on various techniques like, boundary conditions, etc. And, executing a program or application with the intent of examining behaviors, reviewing the deployment infrastructure and associated scripts and automations, and, take part in production activities by using monitoring and observability techniques. And then we have, software testability. So, in software testability, this definition is helpful in giving you know, a broad, uh, a board of, broad perspective of what software testability should be. So, is the degree to which a software system, software module, requirements or design documents supports testing in a given test context. So if the testability of the software artifacts is high, then finding faults in the system if it has any by means of testing is easier. At point that a point that has been made by many is testability. The three components that stood out to me the most are controllability, observability, and observability, isolate ability, meaning the component that is being tested, can it be tested in isolation slash, independently? Can this be tested, you know, separate from, like, your software data and independent from your, um, computer, or from your, whatever application. And now you have, unit testing. So unit testing is a software testing method by which individual units of source code sets one or more computer program modules together with associated control data. Usage procedures and operating procedures are tested to determine whether they are fit for use. And this is a standard step in development and implementation approaches. So the advantages of unit testing is to isolate each part of the program and show the individual parts are correct and usable. This is beneficial because it reduces costs. Uh, you know, you finding any bugs before running, and also states early detection of problems in the cycle. And you have mock objects. So, mock objects are simulated objects that mimic the behavior of real objects in controlled ways. Most often, as part of a software testing initiative, a programmer typically creates a mock object to test the behavior of some other object. In much the same way that a phone is used to check the durability as it's thrown into the ground. The use of mock objects can closely couple the unit tests to the implementation of the code that is being tested. For example, many mock object frameworks allow the developers to check the order of and number of times that mock object methods were invoked by the real object being tested. Subsequent refactoring of the code that's being tested could therefore cause the test to fail, even though all the mock object methods still obey the contract of the previous implementation. So the downside is that the overuse of the mock object as part of a suite of unit tests can result in a dramatic increase in the amount of maintenance that needs to be performed on the test during system, you know, evolution as refactoring takes place. And I think for my final slide, I think 5 questions every unit test must answer. So to me, most of it has been answered by one in particular is, test discipline. So some key examples are, designing. So that's writing test, first gives you a clear perspective on the ideal IPA design. So couple is a few of them are, the feature documentation for developers, test description enshrines and code implemented feature requirements, test your developer understanding. Does the developer understand the problem enough to articulate all the critical component requirements? And also the quality, quality assurance. It's impossible, for a developer to remember all the features that need testing after making a change to refactor, come add new features or remove features. And then you have continuous delivery aid. An automated QA, affords the opportunity to automatically prevent broken builds from being deployed to productions. And so, this was my presentation for the unit test project. And, thank you very much. Thank you.